So I'm going to take you through the steps of performing a correlational analysis, and the idea here is to look at the relationship between two variables. So by running a correlational analysis, we can see if, in this example, height and weight are related to each other or not. So we can see if they correlate positively or negatively. So if the two variables correlate positively, it will mean that as one increases, so will the other. If the correlation comes out as a negative correlation, then we know that as one variable increases, the other decreases. And the other thing we can learn from a correlational analysis is if the correlation is significant or not, so if it's a dramatic finding or not. So let's run the correlational analysis. If you click on Analyze, then Correlate, then Bivariate. Once you've done that, you should see in this new window you have both variables on the left hand side and then an empty box on the right hand side. You literally have to transfer over both variables over to the right hand side, and then really you're good to click OK. So once you've clicked OK, in your output window you'll be able to see a correlation matrix. Obviously the more correlations you run, the bigger this matrix becomes, and it just shows you statistically the relationship between height and weight. So to begin with, you can ignore the diagonal numbers here. So the correlation coefficient between height and height is obviously going to be a perfect correlation, and we're not interested in that. Similarly, the correlation between weight and weight is something that we don't have to pay attention to. We are of course interested in the value between height and weight, or between weight and height. And what spss does is it works out the relationship between height and weight based on a scale from -1 to 1. So if the correlation coefficient has a negative symbol next to it, you then know that there is a negative relationship between height and weight. In this case, the correlation coefficient is 0.449, and this is a positive number, so we can straight away tell that there is a positive correlation between height and weight. Okay. The second thing we can see is the significance of this correlation. So underneath the correlation coefficient we can see the significance value 0.02. Now typically in statistics, any value there under 0.05 is deemed significant, or in other words it's dramatic enough to show that there is a true correlation between height and weight. So our significance is 0.02. That's a very high probability of finding this correlation. So in other words, we have a significantly positive correlation between height and weight.